Hello everyone. In this video, I would like to show you how to plot saddle node bifurcation using MATCONT. To start with MATCONT, first we need to change the current directory to your MATCONT folder. You just have to click on this button and you have to go where you put your MATCONT folder. MATCONT you can download from anywhere. You can have the latest version. Just type MATCONT in Google and you can have MATCONT and put MATCONT anywhere and just click on that, just go to that path and click on MATCONT and just hit OK. So we are right now in MATCONT directory, and as you can see the files under MATCONT on the left side in current directory, and now you have to just write MATCONT and hit enter. Now after hitting enter, you will see a window called MATCONT popping up. Now here first you have to go to select, then system, then new. Here we will give the equations and we'll tell MATCONT what are the coordinates and parameters we are using in this. First give a name, sad, and remember please don't put any space over here. You can use underscore. Coordinates are we are using x, y, z. So here we are having only one coordinate, and I'm naming that as x, and parameter also one parameter, I'm naming that as r. And this thing you can click on symbolically for first three and numerically for last two. The thing is, symbolically, if you keep symbolically, then the calculations will be a little bit slow, and for numerically it's a little bit fast. Accuracy, you just can click first one is symbolically and other four ones as numerically. And here you have to give the equations. We have only one equation, so which is x dot equals to r plus x square. You can give a semicolon, or you can just hit OK, and it will load the system named SAT node bifurcation. So to start with things, first go to type and then initial point. You have to tell MATCONT what the initial point we're using. So in this starter window you will see t equals to 0, all the values are 0. So first we will change the x value and r value to any random values. Say for t equals to 0, x is 0.2 and r we are taking as -2, and hit enter to make sure the values have been taken by MATCONT. And in this integrator window we don't have to do anything, just we have to change the interval to 100. You can give it 1000, you can give it 10, it will take more time in 1000, and hit enter. And now go to window, and we have to open two windows. One is numeric window and one is graphic 2D plot. So in numeric window you can see t and x. So before going into the bifurcation diagram, we have to find the fixed point. So to find the fixed point, we need this numeric window where we'll see the fixed point value, and in this 2D plot we will see how it is varying with time. The x, y, z, the coordinates we have given, how they are varying with time. So in the abscisses we'll put time, and the ordinate it's x, it's fine. So keep it like this and change the plotting region, say from -40 to +40. You can choose anything, -30 to +30, and you can hit enter and just close it. And please remember, don't close this starter window and also the integrator window in case when we are computing. Now we are all done here to find the fixed point. So now we have to come back to the MATCONT window and go to compute and hit forward. So you're seeing x value is almost fixed at 1.41, and the status is ready in the MATCONT window, and the curve it is been saved in p_o1. So we are having a fixed point. You can, if you want to check furthermore, then you can go compute and hit extend. I'm not doing this because the values of x will not change that much. So we are having a fixed point, and that has been confirmed by the graph. As you can see, it's a straight line, it is not varying with time. So now we again have to come to the MATCONT window and select, go to initial point. So P01 was our fixed point, where the fixed point is been stored actually, and it's the last point. So we'll click this and then hit select. Now after clicking select, there will be few windows popping up, and as you can see in starter window, its x value is being changed from our given initial condition 0.1 to this value, and we have to tell MATCONT that this is our equilibrium point. So type initial point and then go to equilibrium. After clicking equilibrium, you will see the starter window being changed to this, and there is a radio button after R, beside R, and R value we have given -2, and you have just to click that R value. So we are done over here. Now we have to come to the plot window, and as you know, bifurcation diagram are between your x and your parameter, so you have to change the variable on axis. Now the variable on axis, just go to coordinate and hit parameter. It will be R. We have only one parameter and coordinate is fine with x. Just click OK. Plotting region are okay. And before doing the bifurcation plot, we just have to do a small thing. Come to numeric window and window layout. You will see there are different things. You just have to click eigenvalues. Why we are clicking the eigenvalues? We want to see the eigenvalues to know properly that a bifurcation diagram, the branch of that bifurcation diagram is positive or not. The eigenvalues, as you know, eigenvalues, if real part of the eigenvalues is negative, then the branch is stable, and if the real part is greater than 0, then it's unstable. So we are done. Just come to compute and hit forward, and you will see eigenvalues are first minus, and it almost came to 0, and we are having LP point. Now MATLAB is showing us, MATCONT actually is showing us the status. See the status in MATCONT window. It's saying limit point. So limit point means where the stability is being exchanged. So to see that, just resume action, and we'll see the real part of the eigenvalues in the numeric window is positive. So the part we are right now seeing on the 2D plot is unstable. It will go on increasing. You can stop the computation, or you can go on with the computation. I'm stopping it. Okay, so we have the upper half. Now for any diagram, for any given equation, if you want to check that furthermore, after the calculation is being finished, you have to check there is any limit point or any other points. You can hit compute extend. But for saddle node bifurcation, as we know that there will be no more limit points, so we are stopping the integration, stopping the calculation. Now we are going to compute, and we have to see other branches, the lower branch, so we are going backward. See, for backward in the numeric window, the eigenvalue is negative. That means the lower part is stable. So the upper part of the limiting point is unstable, as we know, and the lower of the limiting point is stable. So this also go on. If you want to check furthermore, you can, after this is completed, you can hit compute extend, and or you can stop it. So I'm stopping this. So we have our bifurcation diagram, saddle node bifurcation diagram. So this is the bifurcation diagram. You can make it dot dot dot. You can do so many things in this window, and this figure editing window of MATLAB, and you can. And if you want the grids to on, just go to this window and hit grid on, and the grid will be on in your diagram. Grid is on, as you can see, and you can make this line as dot dot dot, and you can make this bold. So this is our bifurcation diagram for saddle node bifurcation. Thank you all.